Okay, this question is pretty representative of what you're going to see in Chapter 4 in the OTCO workbook. About primary treatment. So pretty similar to some questions that you saw last week. So I'm only going to post this example, and hopefully it shouldn't be too much trouble for you to work through these. I apologize for not getting them up a little bit sooner. Had to work on my hot water heater after class Wednesday night, Thursday night, and finally got it working this morning. And also found out yesterday that I'd been exposed to somebody who's COVID positive, so I'm stuck quarantining at home till the middle of next week. But fortunately, that won't affect our class at all. So before I work this problem out, I did want to point out something that some of you probably know, and if you're new to this field, maybe you don't realize, and that's that a lot of flows that we talk about in wastewater treatment are going to be in million gallons per day. Even when they're less than a million gallons per day, typically when we're talking about the flow coming into the plant, we're going to convert it into this unit of measure called million gallons per day. So even a smaller plant that maybe has a flow of 635,000 gallons per day, that flow is going to be expressed as 0.635 million gallons per day. The other thing I want to point out is that sometimes when we're talking about million gallons per day, we're talking about an instantaneous flow. Of course, we do keep track of our daily flow, so we'll keep track of a total flow for a 24-hour period, which is expressed in million gallons per day. So, for example, at the Perrysburg plant, yesterday, if our flow over a 24-hour period from 8 a.m., let's say Wednesday morning, until 8 a.m. Thursday morning was 3,910,000 gallons, we would express that as 3.910 MGD, or million gallons per day. But while that flow is being measured, we'll also take a look at it as an instantaneous measure. So on our flow meter, our peak flow for the day might show up like this: 4.765 MGD in the middle of the afternoon, and then later in that 24-hour period, say early morning, 3 or 4 a.m., it might be as low as 1.962 MGD, and those would be instantaneous flows. And if you can't quite wrap your head around it, think about if you're driving a car. If I'm taking a long trip to, let's say, Florida, it might take me 20 hours. It might take me 20 hours to travel 1,000 miles. So my total miles driven would be 1,000 miles. I could express that as 1,000 miles per day. But at any one time, and if it took me 20 hours to drive that 1,000 miles, I would average 50 miles per hour. But of course, during that 20-hour period, I might be on the expressway driving at any 1.75 miles per hour. And if I stop to get gas, I might be driving 0 miles per hour, or maybe 20 miles per hour through the parking lot or headed towards the on-ramp to get back on the expressway. So typically flows are going to be expressed, as I said, for larger amounts. When we're talking about hundreds of thousands, or sometimes even tens of thousands of gallons of flow in this figure of million gallons per day. And then when we talk about smaller numbers, let's say if we're pumping sludge to a digester, if we're only pumping 10 or 11,000 gallons per day, we would just express that as 10,000 gallons per day. But the reason I bring this up is that when you see these problems, you're going to spend a lot of time converting million gallons per day into cubic feet per second. And as we saw in last week's homework, there is a conversion that you can use as a shortcut if you're comfortable using it. And that is that 1 MGD, I believe, equals 1.55 cubic feet per second. And don't hold me to that. I'm going to actually calculate it on my phone to see if that's right. So 1 million divided by 7.48 divided by 1.55 cubic feet per second equals 1 MGD. So if you wanted to take that shortcut to do this problem, you could multiply 2.5 MGD times 1.55 cubic feet per second per and realize that 2.5 million gallons per day is the equivalent to 3.87 cubic feet per second. So that is a shortcut that you can use. Or if you're old school like me, you can just do the conversion and work it out the old, kind of the long way, which would be converting 2,500,000 gallons divided by 7.48 gallons in a cubic foot would give you cubic feet per day, and then cubic feet in a 24-hour day divided by 86,400 seconds in a 24-hour day would get you to the same amount. So just be aware that is a shortcut that you can use, and it may come in handy for this reason, that a lot of these flow problems, you are converting flow in million gallons per day into cubic feet per second, and then dividing that by area in square feet to get an answer in feet per second, which is how your velocity is going to be expressed. So for the purposes of this problem, we know that our flow rate, 3.87 cubic feet per second. We can calculate our area. We have a 2.75 foot wide channel with water flowing to a depth of 1.25 feet. 2.75 feet times 1.5 feet equals 3.44 square feet, and then at this point it just becomes a division problem. Our flow rate in cubic feet per second divided by our area in square feet is going to give us a velocity in feet per second. And when I divide that out, I come up with an answer of 0.43 feet per second. So, again, very similar to the problems that you had last week that everybody seemed to do well on. So, you should hopefully be able to knock these out pretty quickly. This is the only video I'm going to put up for Chapter 4, and I will get to work on posting them for Chapter 5.